Hello, and welcome to our fourth Ask Me Anything from Interactive AI Magazine. We receive questions from the community and we ask AI experts these questions. So they're your questions. You can learn about our next AMAs at interactiveaimag.org or by signing up for the weekly AI alert at aitopics.org. If you go to aitopics.org and you click the AI alerts at the top, then you'll find a place to add your email in the middle of the page. So today we have Dr. David Leake, Professor of Computer Science in the Luddy School of Informatics at Indiana University. And would you like to introduce yourself further?
Thanks very much, Josh. I'm delighted to be here. I very much appreciate the invitation. It's a great series. So my work is, in AI and cognitive science. I've been working primarily in the area of case-based reasoning for many years. I actually completed my dissertation in 1990. And through that time, I've been fascinated by basically how cognitive science can influence AI and the use of experience, and have worked in a number of areas in addition to case-based reasoning, intelligent user interfaces, work on explanation, which is undergoing a resurgence now. I'm thrilled to see the great level of interest in explanation these days. Exactly, in meta reasoning, and basically I'm very excited about what the state of AI is right now.
Great. I am Chief Architect at I2K Connect, or Joshua Eckroth, as you can see on the title, Chief Architect at I2K Connect and Associate Editor of the Interactive AI Magazine, and I also run AI Topics.
I should actually also mention my connection to AI Magazine. I'm very proud that for 17 years I was honored to be the editor-in-chief of the magazine. And so I'm also thrilled to see the advent of the interactive AI magazine, which is a great development and great advance.
Thanks. Yeah, Ashok Gold started that. And what's, when you call it interactive, it's obviously what's going to be different. Well, things like this AMA, for example, are one of the things that we thought you can't do this with print. So here we are. So you mentioned explanation, and I have some like a question that was kind of later about that, but I'm just curious, since you've been working in explanation for a while, do you feel that it's only recently gotten the attention it's due, or do you feel things have changed and now it's a different kind of explanation that we're talking about?
So actually, it is a different kind of explanation, or there's interest in both kinds. So basically, the two primary kinds, and the one that I focused on primarily in my early work, was explanation for the benefit of an AI system. And so basically, I was doing work on story understanding, on how a system could process a story and detect anomalous events, then explain those events, to which I applied case-based reasoning, basically the idea of getting reminded of a previous anomalous event, and then basically given an explanation, trying to determine when that explanation was useful with respect to the goals of the system. And so if the task domain, the sample domain for my early work was involving stories such as the unexpected death of a racehorse named Swale. It was called the Swale Project. Basically, this was there was a star racehorse who was winning all the important races and then unexpectedly suddenly died. And it was something that captured the imagination of a lot of people, or the interest of a lot of people. The New York Times had a story here, 9 possible explanations for why the racehorse died. And there were a lot of things that were really interesting about it. One was that, of course, no one had sufficient information to definitively establish what the cause of death was. Also, basically, there were just countless factors that one could hypothesize as explanations for this. But on the other hand, people actually seem to not have much problem coming up with plausible explanations. And so the question was how they did that. And one thing that we noticed was that, this was basically working with Roger Scheck, my advisor, that and another, basically a Yale explanation group, was that people tended to get reminded of past deaths. And so there was a runner named Jim Fixx who had died unexpectedly in peak condition, and people were reminded of that. And then people were reminded of things that were much farther fetched than that, which give a certain aspect of creativity. But in explaining that, if one is looking for an explanation, it's very much dependent on context and what the expectations are. And so the explanation for a racehorse dying very young is going to be very different from the explanation for a racehorse whose longevity was unusual. Maybe the old racehorse had been fed the special yogurt that basically contributed to the lifespan. The young one, of course, you're looking for something else. And so basically, there's the aspect of focus on expectations and expectation failures, which turns out to be a really, really powerful way of aiming learning in an AI system. And then there are also things like if the explanation is being generated in order to try to prevent the event from happening in the future, there are certain things that the explanation has to contain. It has to contain things that are causally relevant, but they also have to be observable factors. If the explanation is something that's going to be, say, assigning blame, it may be that it's not as necessary to have the things that are observable in advance, but basically it has to have things that are more under control of certain actors, et cetera. And so there are all sorts of interesting things also from a cognitive science point of view of what makes a good explanation for a particular understander. And so that's one component of explanation, one facet of explanation. Now, a lot of the work in explanation is focused on explaining black box systems. You have systems that are learning using deep neural networks. They're doing amazing things, but it's very hard to say why they're doing them. And so the question is, can one actually, for an external observer, for a human, explain the inner functioning of this system? And so the idea is interpretability. And so there's some very interesting work that's going on now in terms of trying to pair case-based reasoning systems and black box systems, basically saying, is it possible to explain by reference to cases that can be presented to a user effectively what is most significant in the factors that are being taken into account, say, by the deep learning system. But there are certainly overlaps between these two. I mean, one wants to, when explaining a black box system, get the types of factors that are relevant to the observer. And there also is a lot of potential still for using explanations within an AI system, for example, to guide the learning process. One of the things that fascinates me is learning from few examples. There's so much work that involves enormous amounts of examples. In order to learn from few examples, one has to have, or the system, a learner has to have the capability to determine which factors are the most relevant, most important, and explanations are very powerful for that. So I think both of these aspects of explanation are things that are very important, that are going to become even, I think, more important as AI becomes even more prevalent and is used for more and more high impact, high importance, and potentially very critical domains.
Yeah, so there's lots of directions to go with that response. So I was just thinking for one of these directions, it seems like the black box approach is more experimental and maybe more statistics driven, where we would say we can measure, like if you have a sentence, what is CBR, the what and the is, those two words, those tokens probably don't contribute much at all to, nothing really fires for those two tokens, but the CBR token fires a lot of neurons. And so we can say that's the one that's causing the QA system or something to produce the answer. Whereas when you have a symbolic architecture, you can, I guess, you don't need to do the experimental approach. Like your algorithm can tell you these things are what triggered this kind of response. I could be wrong about that, but I'm wondering if, so basically my question is, when you used explanation in CBR, did you have an experimental approach where statistics were involved, or was it not really that style? And do you think that's different with the like explaining a DL architecture?
Yeah, so the approach that we used actually was not a statistical approach. And so basically, the system was relying on previous cases, previous examples in memory, and then a kind of general semantic memory for getting relationships between concepts. A lot of the work actually was trying to develop what we call a content theory of the domain, basically looking at, for example, for expectation failures, in what ways can events differ from expectations? And so there are things like something happens earlier, something happens later, something conflicts with a certain aspect of a plan, something conflicts with the goals of a particular user. And so it was very knowledge-based. And as you say, basically the DL work is statistics-based. There are interesting potential synergies, kind of interesting interplay. For case-based reasoning, for acquiring knowledge, one of the things that is a great strength is that it can be hard to code up, to acquire kind of distilled rules of a particular domain. It's much easier to acquire particular cases. You have, for example, repair people go out in the field, they interact with devices, they do repairs, and then they come back and they tell each other their war stories. And that's a way that they naturally share the information. And so that's a strength for knowledge acquisition, but it's turned out that it's actually much harder, I guess I should say, for the steps of the case-based reasoning process. There's first the retrieval of a prior case and similarity assessment, deciding what is relevant. And then if there are differences, the solution from that previous episode needs to be adapted to account for those differences, to adjust the solution accordingly. And so case adaptation is something that also requires knowledge to guide it. And it can be very hard to acquire that type of knowledge. And so one of the things that we're looking at now actually is how you can use a deep learning approach to actually look at past cases and extract from them knowledge about how to adapt. And so in that way, basically, the statistical information can be useful for finding out how to make the best use of the cases that you have. And likewise, it can be very useful for assessing similarity. And so there can be that sort of interplay between the two approaches.
Yeah, deep learning is good at generalization, for example.
Exactly. Yeah.
So a different direction, and this is a question I was actually asked, but it's completely relevant. The fact that one of those Google engineers claimed that the Lambda chatbot was sentient, that was his experience with that chatbot. The question is technically, what are your thoughts about the fact, the so-called fact, that Lambda is sentient, and how far are we from conscious AI? But I think another way to look at it is, isn't this a clear case of what the role of explanation does for us? And if you don't have an explanation, these kind of things can happen. So basically, what are your thoughts on that?
That's actually a fabulous way of looking at it. Yes. So in terms of the claims for that system being sentient, of course, that's not something that Google is claiming. And that's something that is certainly not the case that it is sentient. It's a chatbot. And as I'm sure the viewers are aware, basically the goal of a chatbot is to, given some input, get a response that appears to be coherent with it. There's a long history in AI of people developing systems that might have interactions along those lines. Of course, even in the mid-'60s, there was the program ELIZA.
Weizenbaum.
Exactly. Yeah, that basically was supposed to be a psychiatrist conversing with a patient. And basically he did it by keyword matching.
He had a stronger reaction to watching people use it too.
Excuse me?
He had a stronger reaction to watching people use it. He thought they got too deep, just like what's happening now.
You know, it's amazing actually, because I at some point brought just a friend to sit down and try it, who knew nothing about AI. And he actually, after about like 3 lines of interaction, he was starting to express some of his deepest thoughts. And it's so easy to get sucked into that, even though, just for the audience, I'll say that it was working entirely on keyword matching. It would have things like it would see the word mother. And so seeing that would say, well, tell me more about your family, etc. And so people basically, I guess it's a reflection of the intelligence of people, actually, that they are able to take things that might not be particularly profound and then hypothesize around them things that would make them make sense if they have a kind of an incentive for doing that. And so basically you have, of course, for the Lambda system, it's basically, it's a fabulous chatbot. It's trained on enormous amounts of information. The text looks extremely compelling. But in fact, as you said, what you need is explanation to know why it is actually saying these things. And if you were to have that explanation, it would reveal that it really is just these correlations with all sorts of things that have been trained, but without any of the deep understanding. But it does raise really interesting questions about, I guess, how far or close we are to deeper understanding and when we might reach that. Something that's interested me for a long time, actually, is AI systems with introspective reasoning, with meta reasoning. And for quite some time, even in the mid-90s and possibly before, AI people have been very interested in that. I actually worked with a student named Susan Fox in the mid-90s on a case-based reasoning system that actually had an inner model of basically how, kind of a device model of how a case-based reasoning system is supposed to perform. And so when it failed, it would actually use that device model to try to diagnose what had gone wrong and then to fix it in order to basically learn to make better use of the cases that would be offered to it. And so it would be things like, I guess one of the examples for that was basically, it was in a simulated robot world. It was trying to navigate with a very poor map. It at some point found, for trying to get from point A to point B, a case that went to a point that was very close to the second point. And it basically, in its simulated world, rolled to that point that was suggested by the old case, and then found that, yes, it was close, but it was on the other side of a river. And so basically, that was an instance where what seemed to be the closest case actually was not, from the point of view of a practical solution, that close a case. And so then the question is, what assumption went wrong in the case-based reasoning process? And of course, the assumption is that the similarity measure that it was using was going to accurately reflect what was making a useful plan. And so from that, it actually was prompted to learn to adjust the similarity measure in order to deal with things like that in the future. And there have been a lot of people working on introspective reasoning, very impressive systems that can significantly benefit the performance of the system. And so that's certainly not anything close to, say, consciousness, sentience systems. But on the other hand, it's illustrating the potential for a pretty rich reasoning that even involves the inner model of the case-based reasoning system, and the potential for such models. And I expect that we'll see those getting better and better. And so the question, I guess, for how long it will take to get systems with extremely rich performance along those lines also relates to things like, how will we characterize that performance? I mean, even just for defining intelligence, there have been lots of different attempts to define how we measure intelligence in AI systems. In fact, what is an AI system? And the definitions have ranged from things like systems that do things that we think reflect intelligence in people, things like playing chess. There have been an intelligent agents definition of basically perceiving things in a world and using effectors to act rationally. There have been definitions that are more cognitive science inspired, saying doing things in a human-like way. And there's even a definition I like very much from Chris Riesbeck, which is AI is basically, the goal of AI is to make computers less stupid, saying that we're not looking for necessarily these really rich esoteric things. We're looking for making computers have the capabilities that people have to deal with the everyday world and common sense world, the things that we kind of take for granted there. And so I think in order to, I guess, understand things like, well, how close we might be to a sentient machine, I think that first we would have to get a better understanding of what we really think that means. And basically, once we have kind of, I guess, a science of what one is looking for and measuring, then it would be possible to give a better assessment of kind of where we are with respect to that.
Yeah, I mean, it took hundreds of years after like the Renaissance to understand that animals like chimps have internal thoughts.
Exactly.
It's
Yeah.
difficult to kind of measure these things if you always see everything from a human perspective
Yeah.
in
But
speech.
yeah, but it is interesting that, I mean, I think one kind of risk for the field of AI now is that there are systems that do have amazing performance, but it can be to some extent superficially amazing. That is, it's easy to ascribe things that are much deeper than what the
Mm-hmm.
system really has. And so that gets exactly to your point of the need for explanation. We need to know not only what the system is saying, what's proposing, but why it's doing it. And at a much more concrete level, of course, if you have a medical diagnosis system that is
Mm-hmm.
going to propose some potentially risky operation, you really want to know why that's being proposed and what the alternatives are. And so there is a lot of space for explaining both kind of simple classification decisions and in AI planning, actually, why is this plan proposed instead of some other plan? What are the trade-offs? And so it's really going to be crucial for AI to attend very carefully to the interaction between the human and the system and how each one of them actually can understand the other one. I mean, for the AI system to be able to serve a human well, it has to know what the goals are. And it may be that
Mm-hmm.
the stated goals are going to capture some of what's important to the person, but not everything. There may be, there actually has been some interesting work under the name of rebel agents, where the idea is that sometimes you'd want an AI system that you tell it to do something, and it would realize that, well, maybe the world has changed, then there'd be a really bad effect that you hadn't anticipated. And so at that point, you'd like some discretion, but also if the system comes back and says that it doesn't want to do that, you would want to know why.
Interesting. Um, with respect to rebel systems and introspection and all that, that sounds like a very valuable thing to have when you've deployed a system because the world changes. Whereas with deep learning, you often are comparing deep learning models by their accuracy on a fixed data set because it's a competition data set. So you want everyone to use the same thing or whatever. But once you deploy this thing, you can get the feedback from users. But in deep learning, it seems like that just becomes more training data. But with CBR, it seems like that you can do more with that. So is that a fair characterization that CBR is especially valuable kind of like post deployment?
That is, and actually another factor that makes it especially valuable is just that case-based reasoning is kind of, it's been characterized as a kind of inertia-free learning, in that basically the moment the system has a new case, at basically effectively zero cost, that can be integrated in with the other knowledge that it had. So instead of actually having to do a massive retraining process, that's immediately accessible.
Yeah, it's an online system.
Exactly. Yeah.
So with all this talk of case-based reasoning, can you give kind of the lay of the land? Is it an architecture? Is it a library that can be brought into existing code? Like, how do people use case-based reasoning?
That's actually a great question. And I guess my favorite way of characterizing it is, this is something due to somebody named Ian Watson. Basically, there was he had a paper, is case-based reasoning a methodology or a technology? And basically the point of that was that really case-based reasoning grew out of work in cognitive science, studying how humans reason from experiences. And there's, so basically the commitment of case-based reasoning is that reasoning is fundamentally memory-based, that it comes from taking specific prior experiences and adapting their solutions to new needs. But it is not committed to being implemented in any particular way. And so you actually can have, for example, neural network applied to case-based reasoning retrieval or adaptation. You can have database systems that store cases. People have done this. And so it's basically, I think, a way of kind of attacking problems. That being said, there exist some case-based reasoning kind of open source or public open access systems for case-based reasoning. There's something called J-Colibri, which has been extensively developed in Madrid. And the idea there is it's basically, it has kind of interfaces to help lower the barrier to entry in developing case-based reasoning systems. And so anyone can get that for free. There's something else called MyCBR, which has similar goals, but it's really focused on the similarity measures and the retrieval aspects. There's actually a Java framework that was done at Indiana University called IUCBRF. And so there exist those pieces of software that anyone can get and start using to apply them to case-based reasoning. And so I think that basically it's kind of a useful technique to consider, especially in domains where there is limited data. It can be very, very powerful if there's limited data, but a certain amount of knowledge in terms of, and it is necessary to have good similarity criteria to retrieve the right cases to apply to a new situation. It can be helpful to have good knowledge for adapting cases. But one of the things that's very powerful about it is that because of the different steps in the process, the fact that you have the cases, you have similarity knowledge, you have adaptation knowledge, there are all these different sources of knowledge that to some extent overlap and can fill in for each other. And so, for example, if there's a domain where it's hard to adapt a case to a new situation, but there are lots of cases, maybe not much adaptation will be needed because there'll always be a really similar case, so you won't have to adapt very far. On the other hand, if it's hard to get cases, but there's a really good theory of how to adapt the cases, then that could be fine too. And so when applying the system, there's a lot of flexibility into basically where the knowledge needs to be placed. And so that gives a lot of latitude how and where to apply case-based reasoning.
Yeah, so it doesn't sound like it's a plug and play kind of module that you turn on and off.
No, yeah.
Because you're going to need this domain knowledge to adapt it correctly.
Yeah. There have been some interesting proposals actually for case-based components, basically taking a case-based reasoning system and just for some other kind of AI system, wrapping it around it. And so acquiring cases that are built up by the other system. One thing that's nice about case-based reasoning is that in addition to learning from successes, it can learn from failures. Basically, if in a previous case, the following thing was done and the system came up with the wrong answer, it can actually warn of those failures. And so you can imagine using that to supplement an existing system and improve performance that way.
Yeah. And what I said is not a criticism, because even though you can grab a transformers model as a, like import, in Python, import transformers or whatever, and you can go fetch a model from a repository, and suddenly you have a classifier or a question answering tool or something like that. Realistically, and if you're going to do something that's for you, kind of a specific situation in production environment, not just a Wikipedia question answer, because that's what the training data was. But if you're not trying to do it for Wikipedia, but your own, you're going to have to inject knowledge all over the place.
Right.
It's not just retraining all the time. It's everything else around that. We like to say that the AI component actually turns out like this big, whereas the whole rest of the software architecture is around that. And most of your time is actually spent on the other things as well. So,
yeah, I like that. Sorry, go ahead.
Go ahead.
I like that observation. And actually, I think that a very interesting potential application area for case-based reasoning is doing things like hyperparameter optimization. There's actually some work that's being done now in Germany on that using case-based reasoning. And in general, just basically for things like even kind of just deciding, which network architecture you want to use, et cetera, a lot of that is based on the experience of a human at this point. And it seems like that's something that could be captured, and then case-based reasoning system could provide support on.
Interesting. You can take the cases, say for image classification, of the various architectures that have been successful to the varying degrees that they are successful, but they have similarities, of course. And if you can somehow represent that, obviously you could represent the architecture as, components and a hierarchy and so forth. then presumably you can make those into cases that could be adapted, almost like a genetic programming kind of approach where it shares subtrees and merges them together and so on.
Absolutely, yeah.
All right, so maybe to go in a different direction, because I do want to get to the questions that the community asked. Is it possible to develop wisdom or artificial wisdom instead of artificial intelligence, so that algorithms would tell us what's wise and unwise? And the person who asks, I think, tries to clarify wise and unwise as predicting long-term consequences of a given action. So what are your thoughts on that?
So, I mean, definitely in principle, I think it is possible. And I think in practice, one can develop right now very useful systems for that type of task. I mean, basically, the idea is for predicting long-term consequences. Often when we look at the people that we consider very wise, we think of these are the people who have been around in the field a long time. They have a lot of experiences. They've seen it all. And basically, when you go to your mentor and want advice in a situation, your mentor will very possibly say, well, I know the similar situation that happened in the past, and here's what happened then. And so I warn you not to do it, or this is a good thing to do. And so it actually fits in extremely well with kind of a case-based approach and with a growing amount of knowledge of specific examples. Another thing that I should specify for case-based reasoning, which I haven't really dwelt on very much, is that often cases are actually very rich structures. And so the idea is that a case might represent an episode in the world. Rather than trying to generalize rules initially, the idea is keep this entire rich situation, and then in the context of a new need, figure out what is relevant and what's important. And so that actually fits into the artificial wisdom in that you can look back, as long as the system can provide some relevant prior situation, then one can compare and contrast and figure out what might apply and what might not apply. And actually, if one looks at how people reason, I mean, basically, I remember that there was actually a news headline at the time of the Iraq War saying, is Iraq another Vietnam? And obviously, these are enormously complicated situations. But by comparing and contrasting and figuring out what's relevant, one can actually get a lot of valuable lessons. And so one can actually imagine having some kind of huge case base of very, very rich cases that can at least help the human to assess what might be relevant here and then make decisions just the same way that a human mentor might be able to kind of prompt thinking about the right sorts of things to make the right decisions in the world or predict what might happen.
I thought that was a pretty hard question, but that's a great answer. What excites you most about AI and what most concerns you?
So for, I mean, one thing that really excites me now, actually, is, as you'll guess from what I've been saying already, is kind of the interplay between knowledge and data. That basically how we can, how AI systems can learn from small data, can kind of do the type of learning that people do. It's interesting looking at some of the triumphs of deep learning. I mean, things like, or just data-based, or data-driven learning in general. I mean, for example, AlphaZero, it was amazing that it could learn to play really good chess. But it did that by playing, I think, over 16 million games. And if one looks at some estimate of how long it would take humans to play those, if that was basically all that they did, I think that comes to like 1,500 years. And so people are obviously doing something different when they're learning chess. And to function well in the world, they have to be able to do that. And likewise, if you have a system that's dealing with medical problems, you don't want it to risk the first 1,500 years of patience before it figures out to do the right thing. And so we do really need the small data systems, but also the big data systems are extremely useful. And so how we can merge those two things and get those capabilities. So that's something I find extremely exciting. And it relates actually also to, well, explanation in order to make the systems useful, but also getting back to the being able to not only explain to a human what the system's doing, but for the system to be able to explain to itself and then get that additional leverage and power. So those are
Mhm.
all things I'm really excited about. I think for concerns, of course, with any extremely powerful technology, AI technology included, one has to look very carefully at how they're being used and potential social ramifications. There is enormous potential for benefit from such systems, but one also has to be concerned about other ways that they could be applied. And so thinking about ethical considerations, I think, is really important. And another thing that is concerning, which I think the question of the chatbot and sentient AI highlighted, is that it's very easy and very natural to look at kind of from an external, perhaps non-expert view of AI systems, and to not necessarily understand their capabilities. And so getting that understanding is going to be really important for people understanding when to trust the systems, what the limitations of the
Mhm.
systems are, and also to avoid potentially a kind of misleading either hope or fear about AI. And so that's something where I think the AI community needs to be attentive to making sure that
Mhm.
the capabilities and limitations of these systems are appropriately understood.
Yeah, some people think AI is just pattern matching, but others think it's sentient. So,
Right, exactly. Yeah.
uh, with respect to concerns and ethics, do you think CBR could contribute to the issues of bias in data sets, like maybe help detect and clean out bias during training?
So I think definitely. I mean, it seems like something very useful is just because case-based reasoning systems can function from limited amounts of data and from um, basically a small set of examples. And for detecting bias, it seems that there also would be the capability to at least define a reasonable set of or collection of adaptation knowledge in order to basically further leverage those examples. It seems like that would be a domain for which it would be very useful. And I know of people who've also been interested in basically using prior cases in order to, say, detect things like internet harassment and so forth
Mm-hmm.
once you have those examples. And so, yeah, it's a very natural way to capture the information. It's something that can be, I think, applied to that sort of task very effectively. And of course, it's also an instance where it's nice to have the explanation of why
Yeah,
something is
exactly.
considered problematic. Yeah.
Exactly. Okay, so for our last question, I threw this one in here. I once asked my PhD advisor, John Josephson at Ohio State, or the Ohio State University, I should say, what he thought about was the biggest advancement that he's seen in computing. And he said the internet, which actually surprised me because what you might normally think is like the exponential rise in computing power or things like
Mhm.
that.
Mhm.
But um, he thought just uh, the availability of everybody to talk to each other at any moment across the world was the game changer. And in my time working at or with AI, I kind of have come to the similar conclusion. We've had all these advancements in hardware, obviously, in algorithms, but I think the biggest change has been the free sharing of code and data and research, like archive.org for preprints, GitHub, and even a specific example like Hugging Face's Transformers models. Anybody can learn this relatively quickly and get a Python file with a few lines of code, and they have an AI system. And when a paper is published on archive.org, very quickly people implement that. Um, if the same advancements were done in a more traditional style, like say how computing was in the 80s before open source and all that, where you'd have these large companies, they'd make these advanced technologies, and then you have to pay a lot of money to license them. And maybe universities would get it like Unix, right? And then that's
Yeah.
spread. But I wonder if you have seen the same thing, that if I would say we're in a revolution, AI ML revolution right now, And I think it's because of that. Do you feel the same way about that?
So I think that's a really good point. And I think that is crucial. I think it's had a huge effect. So I think I basically agree. I see kind of two variants of that I think also maybe even further magnify the benefit that one's had from the internet. One, of course, is in the kind of the subfields of AI that I've been involved in. There is strong cognitive science influence. And so basically having the ability for people to, or the ease of interaction over a wide distribution of areas beyond even AI is certainly extremely beneficial and certainly impactful. But there's another kind of interesting, in a way, flip side of what the internet has been providing, because I think it provides a fascinating domain of study. And of course, for a lot of the some early machine learning work, people were interested, and still are, of course, in recommender systems and basically capturing things like reviews from the point of view of basically case-based reasoning from experience. There are so many experiences that are captured on the internet. It seems like and of course there, as you said already, there are kind of data sources, knowledge sources, ontologies that are captured there.
Yeah.
And so basically there's just this enormously rich range of things that can be exploited by AI systems, that can test the AI theories, can test their scalability. And so it's really nice that in addition to being this fabulous mechanism for accelerating progress, it's also providing a test bed for kind of the experiences of the world that could be drawn on by these AI systems.
Yeah, that's very interesting. All right. Well, thank you very much for your time. That was fascinating. We really appreciate it. And I guess, do you have any parting words?
Well, just thank you so much. I've really enjoyed it. It's a wonderful feature. It's a hugely exciting time to be in AI. Thank you for all your questions, and looking forward to seeing how the coming years continue to accelerate and what develops from them.
Great. All right. Thank you.
Thank you. Bye-bye.
Bye.